Which of the following devices are computers? In fact, they all are. They all have a way of getting information into a computer through an input device. Your keyboard, mouse, microphone, camera, games controller, and touchscreen are all input devices. Once you've input the information, the computer makes decisions and organises it. A bit like how our brain handles information that we gather through our senses. This is called processing. Your brain also stores information for use later on. It's no different for a computer. The information is stored in a computer's memory. After processing the information, the computer gives you the results by putting it somewhere useful, like on a screen or onto paper via a printer, or even by playing sound through speakers. So you see, all these devices are computers because they have the same arrangement for inputting, processing, storing, and outputting information. Even your Raspberry Pi. It has a processing chip, or CPU, that does calculations. The RAM, or memory, stores information the computer is working on, and the graphics chip controls the images that you see on the screen. These tracks carry electrical signals between the components, allowing them to communicate with each other. The USB ports link to devices like your keyboard and mouse, and the ports here help connect to headphones through a speaker jack and a screen through the HDMI port. The Raspberry Pi also has these pins, which allow you to connect it to even more circuitry and control objects like lights and motors to create fabulous contraptions. On the back, you'll find a slot for a micro SD card. This is used to store the software you'll need to interact with all this hardware. Let me show you how. You'll need to use a computer that has an SD card port and an internet connection to visit raspberrypi.org/downloads. The simplest option is to download and save the Noob's zip archive of the operating system. Anything that's stored on the SD card will be overwritten during formatting. So, if the card you're using has any files you want to keep, like photos, make sure you copy them to another computer. You'll need an application like SD Formatter to help you format the card. Insert your SD card into the computer and make a note of the drive letter allocated to it. Select the drive letter for your SD card and then format the card. Select all the files in the Noobs folder you downloaded earlier and copy them into the SD card window. Once the files have all been copied over, you can eject it. Now, let's get everything connected in the right order to see your Raspberry Pi working safely. First, insert the micro SD card into your Raspberry Pi. Next, we need some input and output devices. Connect your mouse and keyboard to one of the USB ports on the Raspberry Pi. Plug in and turn on your monitor and connect it to your Pi with an HDMI cable, like this. Sound will come from your screen if it has speakers, or you can connect headphones to the audio jack. And what about power? Your Raspberry Pi doesn't have a power switch. As soon as you connect it to a power outlet, it will turn on, so we always do this last. Plug a micro USB power supply into a socket and connect it to your Pi. You should see a red LED light up. As it starts, you'll see raspberries appear in the top left-hand corner of your screen, followed by the Noobs installer. This software will walk you through installing the Raspbian operating system. You can customize your Raspberry Pi software to set the right time, date, and language for your location in the Pi Setup Wizard. You'll also be able to connect your Pi to Wi-Fi and check for any software updates. There are lots of applications to help get you started on your digital making and computing journey. So why not take a look at them using the menu system? Hopefully, your Raspberry Pi now looks and feels more like a computer. In our next video, we'll take a closer look at those applications and write a computer program using code. See you then. So they stop. That's.
No, they're still coming up on the frame there. So, yeah, about that. Yeah,
like tragedy. Feelings gone, it can't go wrong. I mean, that also was just as I was hitting maybe age 6.
Ready?
Yeah.
The Pi's camera board is an HD camera which captures high-resolution images. It's pretty much the same as the camera in your phone, and you can use it to take pictures or record video. To attach the Pi camera to your Raspberry Pi, first find the camera port near the Ethernet port. Now, lift up the small tab on the port a few millimeters and then slide in the camera cable. The tab does not come off, it just becomes a bit wobbly. Make sure that the blue side of the camera cable is facing the Ethernet port and press it into the port. Make sure that the cable is level when you push it in. Push the tab back down into place over the port and the camera should be securely attached. You can capture an image and save it to your desktop as pic.jpg by running this script on your Raspberry Pi. One of the simplest and most used components in your toolkit is the LED. This handy acronym stands for Light Emitting Diode. LED bulbs can be used in any application where you need to show something happening or notify the user that something is ready. LEDs only work in a circuit one way, so pay attention to this bit. When connecting an LED to your circuit, you have to remember that the electricity flows from the positive terminal, your numbered pin, into the long leg of the LED, through the diode and back out through the short leg. From there, it can run through other components first, but must always return to a GND or ground pin on your device, or it won't light up. We also add a resistor to the circuit to limit the amount of electricity flowing through the LED, which prevents it burning out. Check your LED closely for a dark patch or sad little cloud if you think this may have occurred. If you're experiencing faults with your LED, check you have it the right way round first, as this is a common error. We show the bulb here connected to pin 12, but you can use any numbered pin on your Raspberry Pi. Whichever pin you choose, remember to use the correct pin number in your script. To light your LED, you can use the following code. The simplest control system for any digital build is the button. In essence, a tactile switch is a small, self-contained mechanism that closes an electrical circuit when you press it. Look closely at the button itself, and you will see that it has 4 small legs underneath, which extend like claws into the breadboard. Think of these legs as single, bent metal wires that are connected when the button is pressed down. This closes a circuit just like a light switch. Electrical current then flows through the button to an input pin. The Raspberry Pi detects this input and can be programmed to respond in some way. In order to make a proper circuit that will close, you'll need to make sure that both the claws on one side of the button are connected to different rows in your breadboard. In other words, if your breadboard is in landscape or sideways, the claws should be on the top and bottom as you attach it. It helps to have one set of claws either side of the spine down the middle of the breadboard, as in this diagram. Make sure the little claws are lined up with the holes and give it a good press into them. Make sure you aren't bending the legs underneath or it won't work. Connect your wires from one numbered pin and one GND pin to the same rows as the legs. It doesn't matter which wire connects to which leg. Test your button works by running this script. With a servo motor, you don't just give it electricity and have it spin endlessly, you also need to give it a control signal, which says to which angle the drive shaft on the servo should rotate. Tell it to rotate to 180 degrees, it will. Tell it to rotate to 20 degrees and it'll go 160 degrees back the other way. Also, most servos don't rotate freely over 360 degrees like a normal motor. The simplest way to use a servo motor is to have it set to its minimum, median, and maximum values using code. Remember though, servo motors are not particularly powerful and won't be able to lift large loads. To connect a servo motor to your Raspberry Pi, find the 3 jumper wires extending from it. Different makes have different coloured wires, but you can be fairly safe in assuming that the 5 volt or power wire will be red, and you should connect that to pin 1. The ground wire will be black or sometimes brown and can be connected to any pin marked GND on your Raspberry Pi. The remaining wire will be your signal wire, which you can attach to any numbered pin. Just remember which pin you are using for your code, if you don't copy the diagram shown here. In this example, we have wired the servo to pin 17. Once you have wired your servo to the Raspberry Pi, you can test its working with this script.
Enabling two-factor authentication is becoming a lot more common. But did you know you can do it on your Raspberry Pi? Now, two-factor authentication is an extra layer of protection. As well as something you know, your password, you'll be asked for another piece of information, a second factor, every time you log in. Now, this could be something you have, like a smartphone, or something you are, like biometric information. What we're going to do is go ahead and set up something you have, your smartphone, to help you protect your Raspberry Pi. Afterwards, once you've enabled two-factor authentication, every time you log in remotely via SSH, you'll be prompted for a verification code as well as your password. You're going to need a smartphone, your laptop, and of course your Raspberry Pi. But before we do that, we're going to make sure that you're running the latest version of the operating system. Upgrading your operating system is the simplest thing you can do to keep your Raspberry Pi secure, and you should do it frequently. And if you're running a relatively recent version of the operating system, you can do it from the command line. Just go ahead and open up a terminal and type sudo apt-get update, sudo apt-get full upgrade. And depending how long it's been since you've done this before, it could take a fair while to upgrade. Don't worry about it, go have a cup of coffee, it's going to be well worth your time. The Raspberry Pi operating system has an SSH server disabled on boot, so we need to enable it if we want to SSH into our Raspberry Pi. And the easiest way to do that is to go to the desktop menu. So go up to the Raspberry Pi icon, go down to Preferences and Raspberry Pi Configuration. Then go to Interfaces and just click to enable SSH and hit OK. Next, we need to tell the SSH daemon to enable challenge response passwords. So go ahead and open the SSH config file. Sudo nano etc ssh sshd config. So we need to change the challenge response authentication from the default no to yes. So just scroll down until you reach challenge response authentication and change that to yes and hit Ctrl X and Y to save. And then we need to restart the SSH daemons. So sudo system control restart SSH. It's a good idea to open up a terminal on your laptop right now and make sure you can still SSH into your Raspberry Pi at this point. Although you won't be prompted for the two-factor authentication code quite yet, it's sensible to check that everything still works at this stage. So the first thing you need to do to install two-factor authentication is to download an app to your phone, one that's going to generate the time-based one-time password. One of the most commonly used is Google Authenticator. It's available for Android, iOS and BlackBerry, and there's even an open source version of the app available on GitHub. So just go to the App Store, go ahead and search for Google Authenticator, and then download it onto your phone. Once you've done that, you can go ahead and open it and begin setup. You can see down at the bottom here we're offered a scan barcode and manual entry. We'll get to that. First, we have to go back to our Raspberry Pi and install the Google Authenticator PAM module. So just go back to your terminal again and it's sudo apt install lib PAM Google Authenticator. Yes to continue. And now we have two-factor authentication installed on both our phone and our Raspberry Pi. We're ready to get things configured. Go ahead and run the Google Authenticator application from the command line without using sudo because we're configuring it for our own user account, the Pi user account. So just type Google Authenticator at the command line and hit return. And answer yes to whether you want time-based tokens. You'll see this looks a bit odd, but if we just resize our terminal window, we have a QR code. don't move forward quite yet. Before you do anything else, you should copy the emergency codes down below the QR code and put them somewhere safe. These codes will let you access the Raspberry Pi and turn off two-factor authentication if you lose your phone. Without them, you won't be able to secure shell into your Raspberry Pi if you lose or break the device you're trying to use to authenticate with. So next, before we continue with Google Authenticator on the Raspberry Pi, we need to set up Google Authenticator on your phone. So go ahead and open the app and hit Scan Barcode. If this is the first time you're using the app, you will be asked whether to give it permissions to open your camera. You should give it those permissions and then you'll have the ability to scan a barcode. So just point your phone at the screen, center the barcode in the green box, and your phone will read it and then start generating one-time passwords. Your phone will generate a new one-time password every 30 seconds. However, this code isn't going to be all that useful until we finish off what we were doing on the Raspberry Pi. So switch back to your terminal window and answer yes when asked whether Google Authenticator should update your .google Authenticator file. Answer yes when asked whether you should disallow multiple uses of the same authentication token. And answer no to increasing the time skew window. And finally, yes to rate limit in order to protect against brute force attacks. We're done here. Now all we have to do is enable two-factor authentication. We're going to go ahead and use the Linux Pluggable Authentication Module, PAM, which provides dynamic authentication support for applications and services to add two-factor authentication to SSH on the Raspberry Pi. So we need to configure PAM to add to FA. So all we need to do is sudo nano/etc pam.d sshd. We're going to need to add the line auth required pam google authenticator.so to the top of this file. You can either do this above or below the line that says @include common auth. Since I prefer to be prompted for my verification code after entering my password, I'm going to add this line after the @include line. If you want to be prompted for the code before entering your password, you should add it before the @include line. So go ahead and type auth required pam google authenticator.so. Then hit Ctrl+X to save the file, yes to write the buffer, and hit return. Now all we have to do is restart the SSH daemons. So sudo system control restart SSH. If everything has gone to plan, next time you SSH into your Raspberry Pi, you should be prompted for a verification code after being prompted for your password. So go to your laptop, open a terminal window, and secure shell into your Raspberry Pi. If this is the first time you've SSH'd into the Pi, you'll be prompted to verify the key fingerprint. Just type yes, and you'll be asked for your password. And now you'll also be asked for your verification code. So grab your phone, open your Authenticator app, and type in the verification code. 638331 is what I have. And you've successfully two-factor authenticated to your Raspberry Pi. You'll now need your phone and the one-time password every time you SSH or SCP to and from your Raspberry Pi. But because of that, you've just given yourself a huge boost to the security of your device. And now you have the Authenticator app on your phone, you should think about where else you can use it, like Google or Amazon or other online accounts. Because two-factor authentication is one of the easiest and most effective tools you have at your disposal to protect yourself online.
Today, you're going to combine your imagination and storytelling skills with coding and use Python to generate a random fairy tale. To write and test our Python code, we're going to use a Python programming environment, or IDE. Create a new project by clicking New. Let's start with a print function and type print, parentheses, quote, hello reader, quote, close parentheses, and save it as storytime. Let's see what happens when we run this program. The message, "Hello reader," should appear in this section here, called the REPL. Any errors in your program will appear as red text with a description. If you get an error, look over the code carefully to make sure everything is correct. Make sure to watch out for capital letters. Print with a lowercase p is not the same as print with an uppercase P. Check that your printed text is between a pair of quotation marks. Also, the print function expects the message to be enclosed between a pair of parentheses or brackets. If you get a bug in your code, click Stop, fix it, and run it again by clicking Run. Next, let's add an input function to prompt the reader to enter their name. Reader name equals input, open parentheses, quote, "What is your name?" quote, close parentheses. Let's break this code down. Reader name equals creates a variable called reader name and assigns it a value. The input and brackets tell our program to use the input function. The quoted text between the brackets, "What is your name?" is the prompt which is outputted to the screen. You can then use print to output the reader's name. So type print, open parentheses, quote, "Hello," space, quote, plus reader name, close parentheses, and click Run. First, it asks for my name, so I type in my answer, Sally, and press Enter. The program then stores my name as a variable and prints it back to the screen. Print and input are two examples of what we call a function. Python has lots of different built-in functions, but each one performs a single task. Now you've mastered the basics, it's time for you to create your own random story generator. First, you need to create some lists of random words for your final story program. A list in Python looks like this. Names equals, open square brackets, quote, "Zara," quote, comma, space, quote, "Ben," quote, comma, space, quote, "Esme," quote, comma, space, quote, "Andrew," quote, comma, space, quote, "Aisha," quote, close square brackets. You can add as many names as you like between quotation marks and separated by commas inside the square brackets. Have a go at creating more lists for places, quests, and roles. Let your imagination run wild. Let's write some code that picks random items from each list to help you generate your story. At the top of your program, type import random to import the random module. Now, let's choose a random word from each of your lists using the choice function. At the bottom of your code, type random name equals random.choice, open parentheses, names, close parentheses. Now you just need a story to insert them into. Bring all the surprise elements together and be as creative as you like. Begin by creating a variable for a story. Story equals quote. Now you can type the start of your story. I'm going to begin mine with, "Once upon a time, there was a quote." Next, I want to generate a random role from the role list. Plus random role plus. Then return to typing the story by opening quotation marks again. Quote, called, quote, the reader's name, plus random name, plus, before writing more of the story. Continue like this until you've used up all of the random variables. There's one last line of code you need to write in order for your final story to appear on the screen. It was the first Python code you learned at the start of the video, the print function. Print, open parentheses, story, close parentheses. You You may find that your program doesn't work first time, or there are some spaces missing between the words in the story. Don't worry, this happens a lot in computer programming. It's probably just due to a typing error. Working out where these errors or bugs are and fixing them is called debugging. Once you find any errors, simply fix them, save the file and run it again. Before long, you'll have your very own random story generator. In our next video, you'll learn how to write a Python program that responds to a physical button connected to a Raspberry Pi. See you next time. If there are any errors in your program, that alarm will sound.
Everything's okay, alarm. Fun, this is good. I'm not going off. Carry on. Rage.